My name's Jay. I work for Flagship Housing, who are a social housing company in Norwich, just based down the road there. So I've been working for them for about 3 years as a technical team lead. There's 3 groups and about 14 developers, soon to be 18 developers. And when I joined, there was 3 years ago. So one of the reasons that we've expanded so rapidly is because we've delivered very high quality software, and the different areas of the business have become quite involved in that and said, right, what you're doing is really good, we'd like some of that as well. So some of the techniques, some of the tools we're using, I'm going to go through here. You have to bear with me, because I keep leaning forward to change these. So if you've got one, yes, that'd be lovely. Cool. Lovely. Right. Sounded good. Let's see if that works a bit then. Okay, so everyone makes mistakes. I have worked with a few developers who say that I never write a bug, my code's always perfect. They don't last long. Everyone makes mistakes. And if you want to get rid of those bugs, then you need to do something about it. And there's kind of different ways of doing it. One is to use manual testing. That's employing people, having them sit there clicking buttons, typing in bits of information and saying, yeah, that works okay, it's fine. The problem with that is that developers are really bad at that. Testers are they have a different mindset to us. And the other problem with that is that it's a slow feedback cycle. So you might have manual testing after you've created a feature, and you might have manual testing when you're doing regression testing, so prior to a release. If those are the only 2 times you're testing, what happens when things go wrong in between that? And if you're doing manual testing before a regression, and you've got like a 10 weeks of work and then 2 weeks of testing, and then you're going to release, well, if you find a major bug in that last 2 weeks, what happens to that release date? So the slow feedback cycle is a real problem with manual testing. So one of the ways of solving that is with automation. And there are 3 kind of ways of automating tests. So this is the test pyramid. Probably seen this already. It's quite common. Unit tests at the bottom here are your broadest set of tests. So you're going to have the most of these, but they do the least good. So a unit test, typically you'll be looking at a single method. You'll be calling it with some known parameters, looking for a return value and saying, yeah, that's correct or that's wrong. Integration tests are the second tier of tests. They'll be looking at the interaction between 2 components. So it could be 2 classes, the way they interact with each other. Could be more than that. There's no real sort of genuine size or scope for it. They're more useful, but in some ways, out of the 3, they're probably the least useful of all. End-to-end tests are the most valuable, but the hardest to do. So end-to-end test is effectively mimicking what a manual user does. So when they go and they type in all this work and they click buttons and things on a website, for example, if you can automate that and you're doing the same thing as your users are doing, then you're getting the most value from it. But they're quite hard to write, they're very hard to maintain, very fragile tests, they break very easily, and they're slow to run. So typically, you might run like we have a project, we've got maybe, I don't know, 3,000 unit tests, we can write in 20 seconds, and the developers will run that after every build. End-to-end tests, we've got 3,000 end-to-end tests in a different project, that takes 90 minutes. So developers can't really run that after every build unless they're very go for lunch or something like that. So to start with, I've got unit testing. So this is C#, just a sample unit test setup. So we've got NUnit here, which is one of the assertion frameworks, and we've got a unit test adapter. And I've got what I've done is we've got a code and test, a project with code, and I've created a test project. So for C#, that's the convention. You don't write your tests in the same project your code's in. It sits in a separate project. I think it's the same for Java and other languages, but not for client-side code. Angular is different. So what we've done here is mimicked the folder structure of. So where we've got folders in the code, we've got the same folders in the tests. The difference is when it comes down to the lowest level, where we have a class called Simple Math, we've got a folder called Simple Math Tests, and The test suffix is purely for namespace collisions, which you get quite a lot of. And then we have a single class per method in the class simple math. And that single class there will have a collection of tests in it. Now there are three main assertion libraries in C#. NUnit is a port of JUnit, which is very big in the Java world. It's the most popular, the most widely used, definitely the one I'd recommend going for. Supports everything. XUnit is kind of more newer. It's one that's used with .NET Core. Microsoft recommend it quite a lot. They're quite big at that at the moment. And then there's an old one which is called MS Test, which it works. That's for the assertion library. Test adapters and console runners. So to do tests in C#, you need two things. You need the assertion library, which is the bit that says, is that, yes or no. You also need either a test runner or a console runner or a test adapter. A test adapter will allow this project to integrate with the built-in tools in Visual Studio or in some sort of CI build you might have. A console runner doesn't need that. A console runner is a separate executable. You can load it up, you can point it to the DLL, it will scan the DLL, identify your tests and allow you to run them independently. All of those assertion libraries come with console runners and adapters. Doesn't matter which you use. So, and this is a sample of the test adapter being used in Visual Studio Test Runner. So this is all the tests. It's scanned the whole thing, identified them, and the function names are the names you see here. And if a test fails, you see the area down the bottom there. So very simple unit test, C#. So we've got a decorator at the top here, and the decorator is what tells the console runner or the test adapter that this is in fact a test. And with NUnit you call them tests, in XUnit they're called facts, same thing. And we've got the assertion down here, which is the bit that says the result from that method should be 4. These are the NUnit parts. Two other things of interest in this unit test is the AAA pattern, arrange, act, assert. So this is my test setup here. This is me actually calling the method with some known parameters, and it's really important to use fixed parameters. I have seen folks using link statements and things to create their logic, and if you start putting code in your test, then you just test the code that's in your test that's testing the test. And this is the assertion, which is saying, does the result actually equal 4? The AAA pattern there, arrange, act, assert, is used in every single unit test framework in every language going. It's the same pattern everywhere. And it's also not just in unit tests, but in other tests as well. So if you get used to using that pattern, then you're kind of good wherever you go. The other convention here, and this is something that's it's not used everywhere, is this SUT, system under test. It's used quite a bit in C#, but I've not seen it used in other languages. I'm told it is a convention, but if it's only used in one place, I'm not quite sure how much of a convention that is. Got the same test in Angular, and in Angular you have Jasmine, Angular uses Jasmine, sorry. React uses Jest. They kind of do the same thing. They're both assertion libraries and test runners put together. I think with Jasmine the test runner is called Karma. With Jest everything's built into one. So exactly the same 3A pattern in pretty much the same structure of the test. The only difference here is you've got a function at the top rather than the class. So a little bit about TDD, test code refactor, or as some of my developers call it, code test refactor the test. If you're doing TDD, the first thing you do is you create a method signature, but you don't put any code in it at all. It's a bad thing, you throw an open exception. Second thing you do is you go to your test library and you write your first test. This is example code. You wouldn't ever see this in production, I imagine. And we're looking for 6 + 7 = 14 here for a simple test. You then go back to your method and you put in the code that meets that test. So that test will now pass. And you'll run that test, you'll see it pass. You'll then go back and you'll write a second test for the second bit of logic that you're testing. And here I've just combined them using test cases, but it's the same thing. Finally, back to your code, fill in the missing bit and remove the thrown implement exception, and that's done. And that's TDD in a nutshell. There's two things that I find are quite important with this. One of which is never write the code first. It's test-driven development, not code-driven tests. And if you do the tests first, you'll find that your code is structured much more sensibly, and you're much less likely to miss out test cases. You haven't got to rely upon code coverage tools. You can just be safe in the knowledge that you've probably got every option there. The other thing is don't write all of the tests and then write all of the code. Do it a bit like that. I've got a couple of developers that do this a lot. I keep telling them not to. They'll write maybe 10, 15 test cases and then try and write the code to meet all those test cases, and their code get into a real muddle, and then they have to go back and adjust the test cases because they haven't thought of something, and it doesn't really work. So don't do it all at once, do it a bit at a time. And it sounds pretty obvious, but don't test private methods. You only test public methods, not private methods. So, dependency injection. If you've got a unit test, you want to test something in isolation. So you don't want to do an integration test. You're not testing two things, you're testing one thing. What do you do with a method like this? You've got two objects that are being newed up here. How can you test this method without interacting with those two? You can't, it's not possible. So you have to use a technique called dependency injection. Dependency injections looks a bit like this. This is the class. We've injected our dependencies as interfaces into the constructor, and then the method here we're using those objects. What this enables us to do is to replace these with objects of our own making, which can be fakes, can be mocked, can be stubbed, not real objects. That means we can test this without worrying about what's happening inside those classes. And the reason we use interfaces here is because the interface allows you to swap out the implementation. It's not, strictly speaking, a correct use of inheritance, but it works. If you were writing the actual code for this, and I don't know if anyone's not done dependency injection before, you might be thinking, well, how do I create my program with all of this up here? Do I new all of this and manually create my first class and then new up everything else and pass it all in? The answer is no, don't do that. Use an inversion of control container, something like AutoFac or structure map. It will create a container full of instantiated classes for you with all dependencies already met, and then you can just pull them out when you need them using maybe service locator pattern, or preferably something like, if it's a website, you might use a service activator where every web request that comes in gets its own copy of that container injected into the controller method. So the first thing you can do, now you've got your dependency injection, is use a fake. A fake is simply a fake implementation. It's returning some known data. It's useful. It'll allow you to do the test, but it's not great. And it's also called a stub. So here we've got a unit test with stubs, and we've put in some fake objects, and we've got this is true. The problem is, what we don't know is, were those methods we're using from the dependent classes called with the right parameters? We don't know, it's all hidden away. And this is the problem with stubs and fakes. Stubs and fakes are kind of interchangeable terms. You can't really tell what's going on. What you can do is use a mock. And this is using mocking language, which is the most popular one with C#. You can use Rhino mocks as well, but mock's very good. And what we've got here is we're mocking it. So we're mocking the interface, and mock will create a sort of a fake copy of that class, and we can then set up stubs on the methods using this syntax here, get customer. We can tell it that we're expecting that specific parameter. We can tell it what to return, and we can mark it as verifiable. And if we do that, at the end down here, we can verify all the mocks. And what I'll do is it'll say that mock was hit in our code with that parameter, well, we know it's good. You can also use different syntax. You can use this verify syntax here, which does the same thing. The only advantage here is you can say how many times you expect that code to be hit. So I put once here, sometimes it's twice. You might want to know how many times. If we're doing the same thing in Jest, it's a little bit different, because Jest doesn't, you have mocks and you have stubs, but it's JavaScript under the hood, and in JavaScript there are no rules, it seems. With Jest, the easy way to do it is spies. So with Jest, you're spying on the actual object. This is a real object. It's not a fake we've created. we're calling the method sum, and we're saying we're going to spy on that, and we're returning the value 4. Now you can also use a different syntax, object equals jest.fn, give it a function, and you can mock it all out that way, and you can pass it in. This is a lot simpler, but they both work. And essentially it's doing exactly the same thing, and we can say that we expect the spy to have been called with those parameters, and this will pass. Incidentally, expect is the syntax for both Jasmine and Jest, their assertions. So, code coverage, or as I like to call it, you've missed a test case. So this is a sample, it's quite a blurry sample, from report generator using OpenCover. OpenCover is an open source code coverage tool. And the way the code coverage tools, all of them really work, is when you're calling your tests, like using a test runner or a test adapter, you're actually calling the code coverage tool, and the code coverage tool is calling your tests for you. And it's got some sort of first-class cleverness where it works out what methods have been hit, what parameters have been used, and all that kind of stuff. And it captures all the statistics for you and displays them in something like this. So here you can see all my, I think my classes down here, and you can see how many lines have been covered, how many lines are uncovered, and the percentages there. It's quite interesting that you have both line coverage and branch coverage. And the reason for that is you might have a single line conditional, but you're only checking one half of it, in which case you can get 100% line coverage but not 100% branch coverage. It's important to look at both of those. You've also got two other things here, these lovely things here, end-path complexity, cyclomatic complexity. Now, the algorithm for end-path is actually broken there, so that's not right. But end-path complexity is very, very complicated. If you want to find the actual algorithm, it's behind a paywall, some sort of scientific research paper, and no one can ever get hold of it. But essentially, it's 2 to the power the number of paths through the code, and it's pretty useless. Don't use it. Cyclomatic complexity is much more useful. It's used a lot, and is just the number of paths through the code. So if you have a function that returns a single value, returns 4, you'll have a cyclomatic complexity of 1. That's the simplest possible method you can get. If it had an if statement, it would have a cyclomatic complexity of 2. You've got 2 values. If it was 2 if statements, one nested inside the other, it would be 3 possible values. And that's useful because that tells you how many test cases you need to fully test that method. So there should be a correlation between the two. And the usual rule is if you have a cyclomatic complexity of greater than 20, that's a bad thing. For some reason here it's green, which is good. I don't know why that is. That's one of the defaults built into OpenCover. OpenCover supports .NET Framework and .NET Core. It's open source, so anyone can use it. It is a bit finicky to use. There's an easier one called Coverlet, which supports core only. The problem with Coverlet is it doesn't give you cyclomatic complexity. Sorry. If you're using Jasmine, you would need to use Istanbul Reporter, or Istanbul I think it's just called, which will capture the code coverage for you. If you're using Jest, it's built in, does it for you. I mean, it probably uses the same thing under the hood, I don't know, but it works. And the actual format of it is exactly the same because it uses the same report writing tool, a different port of it. So this is a little sample of what we do at Flagship with our code coverage. So we export that as a code coverage XML file in Coptura format, and we export our test report in JUnit format, which is from the Java world, and we snap these into our CI build. So we've got these summaries here, and we can download the detailed reports. But this means we can also put rules in place. So we can say, well, you're not allowed to check in unless your code is higher than the last code coverage. So if it's 80%, you check your code in at 79%, sorry, no, we're not accepting that, you can't have it. You can set minimums. We don't. That's something we're looking into right at this moment because we find that otherwise the code reviewers who are looking at this and should be making sure all the tests are there and the code coverage is quite high, don't do it, they miss it, they forget to do it. So we're trying to enforce that as a rule. So, integration testing. So this is Angular 7 in fact. In Angular you have services which are just classes. You also have components, and Angular components are a bit strange in that they're not made up of one thing, they're made up of 3 things or more. So what we have is we have a class, you've got an empty class at the bottom here. We have a template, which is a HTML template with some Angular directives and little bits and hooks and things in there. And we have a style sheet, a SAS style sheet. Now with Angular, there's three ways of doing unit tests. There's what they call a unit test, a shallow integration test, a deep integration test, but they're all done in the form of unit tests, just to make it more confusing. If you're doing a pure unit test in Angular, you'd be testing methods on a class and you'd ignore the template, you wouldn't do anything with that at all. If you want to do integration test with Angular, or what they call an Angular recommended unit test, you also need to make sure that your template's okay. So you're interacting with the HTML components, which themselves are data bound using the Angular framework with objects in the class, and you're then checking the results. It gets very, very complicated. So this is a sample Angular test, and this is why I was talking to someone earlier on saying that I'm not a big fan of Angular. This is one of the reasons why. In Angular you have a testbed, which is like a testing module, and the testbed does all that compilation for you. It puts everything together as one thing. So I'm declaring a busy indicator component here, which is the class I'm testing. I have to compile it to get everything into one. I've then got to pull out a fixture and the actual component, and only then can I do a test. And this is a smoke test. It's a very standard thing in Angular. You just make sure that it compiles okay. All of that is just to get started. And if you start putting in mocks and other things here, this before each can get large, very large. And there's one. This is one of our sample tests. This is a real test. Each of these lines here is a helper function with 3 or 4 lines of code in there, doing effectively this. So it's going to the, it's using a CSS selector to go and find something out, pull it down, click a button, or do something along those lines. That's a very long test. And I think the actual thing it's testing is just pressing a button. Simple as that. So Angular tests are really integration tests, and they're quite complicated. They're not unit tests. So there is a different way of testing, and this is built into Jest. So if you're using React, you've got this already. You can use Jest with Angular. It's quite easy to do. And it's called snapshot testing, and I haven't got examples of this, so I've not really used it. We don't tend to use it much. But snapshot testing, you call a method, you get the result back, and you manually verify that it's correct. You serialize it to disk and save it, and the next time your tests run, they'll serialize the output and match it to the one you've already manually verified. It sounds like a great idea, as long as your testers or developers make sure that they do manually verify that first output. It's not going to happen. Especially when you get someone, they've got a whole 100 tests that are all broken all of a sudden, they're not going to verify that. So end-to-end testing, sort of the last bit of that triangle. End-to-end testing is, I realised I missed out the C# integration testing. Apologies, I should say that. If you do integration testing in C#, it's a little bit different because there's different ways of doing it. I'll tell you how we do it. We have a lot of microservices. They're mainly REST-based. They also have like a messaging, mass transit messaging format. So we've got 2 ways of getting information in and out. And we have lots of databases behind them. So we do integration testing on all of our services. The way we do that is we create a project in our C# service. We fake up an HTTP client, like an actual web server, like a memory web server, and we call our DLL, our real DLL, and we run it inside that. But what we do is we pass it a in-memory connection string for a entity framework memory database. And we also do the same thing. We have a AMPQ client, which is a messaging client, which we can use to fake up our messaging bus. That enables us to test effectively our microservice from end to end, so all of the parts of our microservice, but without using the user interface, without any of the other services. It's that one component in isolation, but it's all the classes inside that component. It's kind of a large integration test. That's how we do it. You can do it less than that. You could just do 2 classes if you wanted to, but I don't think there's any real consensus about what you should do with integration testing. End-to-end testing, on the other hand, is different. It's brilliant. It's really, really good, really, really useful. I think The Guardian use end-to-end testing for their critical path tests. They also have unit tests. They have no integration tests at all. So maybe that's the way to go. We've got quite a lot of these, and we're actually increasing them. The reason we're increasing them is not because we like the pain of writing them, but because we've found it quite useful to doing it. and that tool is called Catalan. It's not perfect, but it works very, very well. Now this is a sample from Catalan, so what we've got here is one test, and you'll have a test suite or multiple test suites. Each test suite will have various tests inside there. Each test looks like this. So you've got a whole series of steps, and you can recognise this is a website, by the way, we're testing here. You've got objects and you've got inputs. The inputs are the information we're putting in. So if we're typing into a input box, that's the information you'd see in here, and this will identify the input box, usually by CSS, sometimes by XPath. So for example here, this is one of the boxes, lots and lots of XPath there. Now Catalan will allow you to, your testers in fact, if you've got testers, to record all this information. They can click, 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 record it, save it to disk, and then you can automate it and replay it as much as you like. There are some downsides with any record and replay tool, one of which is that this is quite fragile and can break, and if a component moves, it dies. And you also, when you are recording them, you'll get lots of duplicates. So whoever does that job has to be quite aware of that and has to be quite neat and tidy and make sure that everything's how it should be. The other problem with this in general, is that it's no good for Windows Forms apps or WPF apps. This works based on XPath and attributes, which is perfect for websites, but if you're using Windows Forms app, that's not going to work. A lot of other competing products, most of them in fact I'd say, use coordinate systems. So effectively they do the recording, but what they record is your mouse movements and your key presses. So it'll say, right, move mouse up to here, type some buttons in, move mouse to here, click. That's great until someone changes the screen size, and then it breaks. The whole lot break in one go. And also, more for, if you can always fix the screen size if it's a continuous integration server, but if someone says, right, that button there, now I need it moved 5 pixels to the left, just broken away tests. Unfortunately, if you're doing Windows Forms apps or WPF apps or anything like that, you don't really have a choice. You're kind of stuck with it for now. I've heard of some very, very expensive tools that will actually look into the subsystem and somehow identify the different parts of the screen by name or something like that. I've never seen one used, and when I say very expensive, like tens of thousands of pounds, so I probably won't ever see one used. So another bit, I was about behavioural driven development. This is something we've done quite a bit of this in the past, not so much recently. The big advantage of behavioural driven development is this bit here, is English. So if you were starting out a new project, Scrum project, and you were talking to your stakeholders and you sort of went through with them and you said, well, okay, what do you want and what's the acceptance criteria, you can actually turn that into set tests. And this is very, anyone in our business can read this and understand it, even the most technophobic folks. The syntax is quite simple. Feature is like the name of the test suite, scenario is the name of the test, and then we have a syntax. Again, like the AAA syntax, 3 things, given, when, then. And it's effectively the same. Given is your test setup, when is what you do, and then is the assertions, the results. Now, if you're using Java, I think the language is called Gherkin. You have a product called Cucumber, which does this. In the C# world, we don't have that, but we have a port of it called SpecFlow. And there's a URL there which is very, very good about getting this started. You have to install the SpecFlow extension into Visual Studio to get the SpecFlow templates to generate this, because this is all auto-generated. You fill this out, and then what you get is a class with this behind the scenes, all empty, with none of this bit here, ready for you to fill out. And you can see the bindings up here, so the givens bound, the whens bound, the thens bound. This is a very short test I've just written for this demo. We're using Chrome driver, which is and Selenium, and we're navigating to the URL. We're clicking, again CSS, so not coordinates, and we're asserting the value. Now, that's great. If you were doing this a lot, you probably wouldn't do your page objects in there. You'd have a separate class. So for every web page, you'd have its own class. You'd expose all the elements on that page as page objects, and then these steps would interact with those objects. Otherwise, you're going to end up duplicating a lot of code. And that page object model, you actually see it in Catalan. A lot of other products, it seems to be very common. Everyone's using it. Cool. I'm whipping through a bit too quickly, I think. So I've got a couple of little... Yeah, I timed myself yesterday at 45 minutes dead on. I'm half an hour, so I'm definitely going quickly. My wife will tell me off talking too fast. So a couple of little useful tools. Fluent assertions, and this is C# only, I'm afraid, so if you're using client side, you're not going to see this. With this test here, the language could be improved. So that was assert.isEquals. Fluent assertions is a library you can download, and it wraps NUnit or XUnit or whatever, MS Test for that matter, and it gives you a more friendly syntax, a more readable syntax. So rather than saying assert R equal, you can say actual should be 4. It's much more readable. It gets better if you're doing more complicated assertions. So here's a sort, and we've got two things sorted in order. So alpha then beta, we've obviously got it in reverse there, and that's what we're expecting. If we had 100 things on that line, which I'm not sure we would, but just for example's sake, you'd have quite a long assertion list down here. You could do it, and I have seen this, so I put it on here, using a loop. I mentioned before about not putting code in tests, and this is one of the reasons why. This is bad because it will throw the wrong kind of exception if it's wrong, potentially. If this returned too few objects, and if it returned too many objects, it would pass, because the loop is only looking at expected.count, not actual.count. So that's not a good idea. In fluent assertions, you can do it like this. You can put your expected on the alpha beta. You can simply say actual should be equivalent to, and then in options use strict ordering. Much nicer way of writing it. So it's kind of useful. It's again an open source free package, but it's very useful if you're doing C# work. I definitely use it. Another one which I'm guessing most people in the C# will already know about is auto fixture, which is creating fake data. So in auto fixture, it's very simple. You download the package, you create a new fixture, and then you use it to build objects. So I've built an address and I've given it a couple of parameters. I've got a fake address. Now address could have 100 different fields. An auto fixture would fill out all the other fields with fake data. And there's a web page where they tell you exactly how they do it. And the numbers tend to be sequential. The strings tend to be GUIDs with string on the end. But it's very useful. It's much easier than manually writing everything out. If you're using Angular or React or JavaScript, there's a library called Faker, which does something similar. It doesn't do it at the class level, unfortunately. It does it at the property level, but it will give you actual first names, actual addresses, American admittedly, but they're still useful addresses, and dates. You can ask for a past date or a present date. And that is it. I've gone through far too quickly. It's very dark in here now.
Thank you very much.
Any questions at all?
I've just got one.
Yeah, go for it.
It seems to me all this hard work and everything everyone has to do, right, all this code and everything, it just seems like it's just geared towards artificial intelligence. So do you know of anyone developing artificial intelligence-based test helpers that will help us do it?
Yeah.
To write it all ourselves?
It would be nice, wouldn't it?
Well, like just that database one you had there with all the addresses and that, just artificial intelligence.
Yeah, there are services you can buy that will provide you with test data, and they'll handle that. A bit like anonymising services that will anonymise your test databases. I don't know of anyone doing AI for tests, although I do know of an architect in San Francisco that says we'll all be automated in 10 years' time. There'll be no developers, we'll all be...
He's wrong. So there's actually rather than using AI to build up these complex objects, there's another way of doing your tests, something that you can do in Go and Python. Because of the way their interface structure works, you actually work with very small interfaces. So what you're mocking out tends to be a lot smaller, and you don't have to worry about the fact that you've got 100 fields you've got. Unfortunately, other languages, because of the way their interfaces work, you can't do that, but
Yeah.
There are alternatives for some other languages.
Yeah, that's one of the big problems I've seen in unit testing is too many dependencies. We have classes that might have like 10 dependencies, and well, actually, is that really one class? Is that adhering to a single responsibility principle? Are you doing too much in that one class? It's kind of a sign of bad code, really.
So one of the examples they use with Go is with a database. You don't need an entire database object. You just turn around and go write something that can do a query. JavaScript as well.
Yeah, I'll give it a go. I'm not a JavaScript expert, I'm more the C# side, but I've got some colleagues that are a lot better than I am, so I'll point in their direction. Yeah. Any more? Yeah, go.
Are you doing continuous integration at all?
Yes, we are. Well, I say we're doing continuous integration, but not continuous deployment. So we don't press a button, check it in, it goes to live. It goes to like a staging server, and there is some manual intervention there. But yeah, essentially, we're using Git flow, which is a system of managing your source code. So we have a development branch, and we create a feature branch off. We work on our feature branch, and the developer doing that is responsible for making sure the unit tests pass. They check that in, and we run all of our unit tests. Also, our integration tests, they're all automated. Once that has been peer code reviewed, and we do still have manual testers that will manually take a look at it, that will then get merged into our main development branch, and after a period of time we'll do a release, and at the release we'll deploy it to a staging server. Regression tests are running automatically in the background, end-to-end tests, which are also our regression tests, are running automatically in the background all the while. Assuming they all pass and our tester's happy, we'll deploy it to live. But part of the reason for us not doing CD is because if we deploy to live and the business aren't ready for it, I get a lot of flack. So I prefer to keep them happy. Yeah, cool. Sorry, one there?
That's right.
Oh, Sam. Yeah.
So how often are you deploying it?
Every 2 weeks we deploy. So it's sometimes more often, but especially if it's a hot fix, definitely more often. But
You don't need hot fixes because you're all...
yeah, we're not quite there yet. Cool. Yeah.
What CI tools do you use? So sort of like Jenkins or?
TFS. We're TFS based. We're there's 3 work streams. I do one work stream, and we're kind of like the legacy work stream at the moment, I think. So we're TFS. There is another work stream who are using Azure pipes, and all I hear about every lunchtime is how good it is, and I can't use it yet. So, but that's the way we're moving as a company. Everything cloud based. Yeah. Go for it.
Can you explain the differences between sort of MS tests, NUnit and XUnit? And sort of reasons why maybe MS test is frowned upon?
Yeah, to be honest, I've not used MS Test a huge amount, so I can't say too much about it. I know that all of them do the same thing, so you can do whatever you need to do in any of them. It's no difference really. There is one small technical detail between XUnit and NUnit to do with test setups. I believe there's something you can do in NUnit, I can't remember the details of what it is. There's something you can do in NUnit that you can't do in XUnit that's considered to be bad practice. So for that reason, it's kind of XUnit is preferred, but NUnit is more widely supported, so it's kind of like swings and roundabouts. I prefer NUnit. I've got a colleague who uses XUnit, but yeah, either works.
We're more or less doing the same job really, it's just a change of name.
Exactly, yeah. The biggest thing for us was making sure that the test adapters and the console runners work with all the tools we use. So that was more important than the assertion language.
Do you do any black box testing at all?
End-to-end tests are black box,
Yeah.
because obviously the person writing them doesn't necessarily know what the code is like.
Okay.
That's really it. There's no other black box testing.
With Catalan,
Mhm.
obviously you had XPath there, which are an awful thing to use. Does it allow the use of custom attributes?
Yes. So on the screen I had there, where I had like the XPath shown, there was 2 other tabs. One of the tabs was marked attributes. If you click on that tab, you can select any attribute. You can type your own in. You can put any value in there, and you can do things like equals, contains. We've got a BDD library where we put data attributes on, and we use that just for acceptance tests. We abandoned that because effectively we're writing code for tests, which we do what we want to do. In the current thing with Catalan, we're actually using classes quite a lot, and we're just looking at IDs, classes, whatever's most appropriate. The problem with using IDs is that we're using Angular and Materials randomly generates the IDs, so they're not so good.